Okay, let's look at a different example involving promises. It gets a little bit more complicated. What we're going to do is we're first going to define a variable called is dad employed and set it equal to true. Now I use a let instead of var because I'm either in a function or in a function block. The scoping of let is different than the scoping of var. So var has function block scope, could be wind up in global scope. Let has block scope. So usually it's safer, and it's something that we use in TypeScript. Okay, so what I do is I define a new promise, and let's suppose I'm in a function. I do a constant. Will son get toys? And I define a new promise. Okay. In the promise, it immediately invokes the past and function. So I define a function which has a resolve and reject. And I say, if is dad employed is true, I let toy equal to some JSON data, and I resolve the toy. Now notice this let has block scope. Okay. So it declares the variable toy inside this particular block. Okay, and then I resolve the toy in this if block. Else, I say let reason equal a new error. That is broke. I reject and I define the reason. So basically, we're either going to get the toy or we're going to get some rejection reason in our callback when we define a callback for this promise. But keep in mind, the function is executing, so I could log the state as well. But we'll find that when we do chaining of some of these promises, I just noticed here one of the issues that I had, and I just recognized it, was this let is scope of this block. If this let was up here with this toy, I would have been able to chain it with other promises. But we'll talk about that later. Okay, so now let me continue this example. Notice is dad employed is true, so this should resolve. Then I define a function called find result. And this is function, the terminology is I'm consuming the promise. It calls the function's callback. Okay? So I have a constant find result, and it's a function. And what it does is it calls the callback of the promise will son get toys. And so in its callback, we invoke a function and we get the good news, and yes, son will get the toy. This good news comes from the resolution. Right? And it's the toy. Okay? Or anything that any string that I've constructed using that toy object. And we log the good news. And if it was rejected, then basically we have an error, and we invoke this function, and the error gets passed into this function. And I make this comment, oops, that is broke again, but the error message might just say something simple. So if this function is going to consume the promise, we execute the function. Okay, so basically what we see is if is dad employed is true, we see the output. The promise is fulfilled, we see the object that the son will get. if is dad employed is false, we'll see this output. The promise was rejected. We'll see dad is broke. And I just want to point out there's only one resolution. There's one state in the resolution. It's either fulfilled or it's rejected. So that makes it less confusing. But at the same time, try to be careful with your coding and the way you do things, because I find the example I just went over a little bit abstract. And for example, I compare this to Node.js async module, where you're doing a waterfall, you're doing this task or that task, and it's very clear that you're doing things in parallel, or you're doing things in a waterfall method, and you have structures of code. It's like the Angular 1 success and failure block. It was kind of clear about what you were doing. The asynchronous nature was confusing. But when you start writing code like this, just make sure that you don't make it too complicated. If you're calling web services, use the HTTP client module, use the RxJS package to aggregate web service parallel results. There's a lot of things you can do. Okay, so let's look at the basic example of a promise, which might demonstrate some of this. Okay, so let's go back to, what we're going to do is we're going to click on this button and show you a basic function execution of the app component. Okay, so it's the same example we just talked about. First, I have this function called basic. First, I log beginning the basic function. I also log ending the basic function. But in the middle of those, I do a let is dad employed is true. Will son get toys? I instantiate a new promise. It executes this function, and I log basic promise is executing. I get this toy. I resolve the toy. That enables me to take this scoped object and pass it to a callback or a chain. Okay. Else, dad is not employed, son will not get the toy. I reject it for that reason, and so I won't see that rejection unless I change this value up here to false. But let's look at the successful fulfillment of this promise first. Okay, then I consume the promise. So I define this find result function, and it does a then. This is the callback of the promise, and I get the good news. Whatever that is, I log it. That's the resolution of the promise. It gets handed to me. And basically what I do is I say promise is resolved, son will get toy, and I show you the good news, which should be the toy object. And if there's an error, I say oops, dad is broke, and I log the error coming in, which is the reason why it was rejected. And there's a message in that, so I just log that. And then I execute find result. And then I log end the basic function. So what you'll see here is there's a lot of asynchronous stuff here going on. And let's see how that gets logged in our application. So once again, our application is running. I'm going to clear out the console, and this is the basic function which invokes my basic function in my app component. So it looks like things happen pretty quickly. The beginning of the function, I log begin basic. I instantiate the promise. the function and basic, the console gets logged, and then I consume the promise, and it says promise resolved, son will get toy, and I logged a toy. Now maybe the beginning and end is confusing you. It will if you have multiple executions of these different functions. So I'm tempted to remove them, but I want to show you the asynchronous nature of some of these code structures, so I'm leaving it in. And you'll find that when you're doing coding in Angular, you'll see a lot of this stuff. And sometimes it's disturbing because you want to see an asynchronous log, so you understand that it's working right. But Angular is not asynchronous. It's not synchronous. It's asynchronous in nature. So we'll show you how to control that with our async wait example. But let's just show it once more. Happens very quickly. And now let's go and change it. I say, you know what, data's not employed, and I call it false. And in this case here, this if does not execute. So we're going to give a reason why the promise is rejected, because dad's not employed, he can't make any money, he can't buy you the toy. And then when you consume the promise, you don't get a successful result. You get an error result. And so this error message will get logged. When you execute the function which consumes the promise, you'll see the error message. So let's take a look at that. Okay, we execute basic. Begin basic, end basic. Basic promise is executing. Dad is not employed. Son will not get toys for Christmas. So let me just go back once more and revert this back to the way I want it before I leave this example. Notice that could be a dynamic value, right? If we're calling a web service, we want to make sure the data is there and we get a successful result, or did an exception get thrown, in which case we're going to reject the promise. So there's other scenarios here. The dynamics of the data is really important to understand. But let's go back now and take a look. Basic promise is executing, promise resolves, son will get toy, and here's the toy that we're going to get him. Needless to say, I bought my son a PlayStation 4 for Christmas, even though dad is broke. Okay, let's move on to the other examples in the course.